sum of the masses M1 and A1 plus M2 A2 all over A1 plus A2. Because they are just 2, that's why I stopped here. If they are 3, it will be M3 A3 over A1 plus A2 plus A3. So now, we can have, I have my M1. M1 is the mass, that's 16. A1 is 90. Plus M2 is 18. A2 is 10. You can see that 10 and 90 sum up to 100. That's what I was saying the other time. So A1 plus A2, that's what? 100. So if you do that calculation, you should get probably 16 point something. So you should get like 16.2. And it has no units. Relative has no units. So this is one way to do it. If you want to use that second formula, it's the same thing as saying, it's the same thing, but it's just that that one, you will be doing it in fractions. Plus M to A2. You will do it in fractions. 100% is almost like saying A1 plus A2 is equal to 100%. Or A1 plus A2 is equal to 1. It's still like fraction. Or better still, you first do it. This will now be M1. Your M1 is 16 times A1, 90. But you must turn it to fraction. So you divide it by 100. Plus M2, 18 times A2, 10. And you also divide that by 100. To convert it to fraction back. So it's still the same thing. Dividing everything by 100 is the same thing. So that's how to solve this one. This is the formula. Then the second one, this one now, let's use the second formula. We were given the relative atomic mass of chlorine prepared in the laboratory to be 35.5. So we were given the relative atomic mass to be 35.5. So they now said that assuming that chlorine contains 2 isotopes of mass numbers, so M1 equals 35 and N2 equals 37. They now said, what is the percentage composition of the isotope of mass number 35? What are we looking for? A1. But if you use this formula, you might have some bit of problems. Because you know M2, you know M1, you know this, but you don't know A1 and A2. So that means you have 2 unknown and it will be a problem. That's why this second formula works. You can say A1 plus A2 is equal to 1. So I can say A2 is equal to 1 minus A1. So that if I write my relative atomic mass, which is equal to M1 A1 plus M2 A2, my A2 is already 1 minus A1. So that this unknown can be reduced to just what I know. Then I can say the relative atomic mass is going to be M1 A1 plus M2 into 1 minus A1. Meaning that I've reduced the 2 unknown now to just 1 unknown. Do you get that? So now what's my relative atomic mass? 35.5. What's my mass? 35. What am I looking for? A1. Plus what's my N2? 37. Then 1 minus A1. So I do my basic mathematics. So I have 35.5 equals 35A1 plus 37 minus 37A1. So collect the like terms. 35.5 minus 37 is going to be 35A1 minus 37A1. So from there I have minus 1 over 5 and there is going to be minus 2A1. So minus minus goes and I can have my A1 to be 1.5 divided by 2 and that should be around 2. So you can do this way too, like this is more like saying 15. If you want to do basic math, 15 times 10 is per shade. So 15 divided by 2, that's 7.5 times 10 is per minus 1. In case, so that is like 0.75. So, but that is a fraction. So to convert it to percentage now, you can now say collect your percentage. Percentage of A1 is going to be 0.75. All over what's the total? 1 times 100. And that will give me 75%. So Can I rub the board? But I can rub this part, right? I would have said that we should just be using Saturdays to come around to be solving questions. But not the case we have done. Can we move on?
Yes.
Can I rub this one? Please, do you understand what I've done? But here now, imagine that the question says that we should calculate the abundance of that of 37. After we have gotten A1 to be 0.75, we will now bring it here. Then that will be 1 minus 0.75, then that will give you A2. Then that's how you solve for A2. Can I move on? Are you true?
Yeah.
So when you see a question like this, just like that number 12, so they said that an element has two isotopes, X20, X22, and in the ratio of the abundance, 1:3. So you have to calculate the relative atomic mass of X. So the mass number, mass M1 is equal to 20, and M2 is equal to 22. So your A1 ratio A2 is equal to 1:3. What does that mean? That's like 25:75. Shake it. But all the same, let's use our formula. So now we can say that your relative atomic mass is going to be M1A1 plus M2A2, and your M1 is 20 multiplied by A1, which is the ratio of 1, plus M2, that is going to be 22 multiplied by 3. And that's going to be 20 plus 66. Yeah? Sorry, the fractions over 4, but you can just divide everything by 4. Is that 66? Yeah?
Yeah.
So that's what? 36. So you divide it by the entire fraction. So that's 86 over 4. That's what? Don't be confused though, this is what I did. RAM is equal to M1 A1 plus N2 A2 over A1 plus A2. And my M1 is 20 times 3 times 1 plus 22 times 3, all divided by 4. Sure you get? Yes. So that's what we did. Or you could have just carried your fractions along. So you can solve this one. Yes, now you should.
It's not giving us the same answer.
It's not giving the same answer.
Yes.
1:3 is what?
25 ratio.
And you are not getting the same answer.
Yes.
That is still 1:3. Are you dividing it by 4?
No, I was not in my own.
Why is not now getting the same answer? So that's going to be RAM equals 20 times 25 over 100. This is Still like say 20 plus 22 times. It should be the same answer. Still go with what did they call your name the other time? Josephine. That's actually June. So please, these are the three ways questions and formats. Please, do we understand that? Can we move on? So the next thing to define is allotropy. Allotropy. Can I rub the board? Can I rub the board? Scan. Reject it. Please stay back. Let's keep quiet, please. So let's, please. Don't know how annoying your question. So, allotropy is the existence of an element in different physical forms or same physical states. They exist in different forms, different physical forms, but the same physical states, like allotropy. So, like they can exist as solid, but having different shapes, different forms, will exist as solid. So that's what I mean by same physical states, but different physical forms. So that's allotropy. So elements have that ability. So we have what we call allotropes of carbon. What are the allotropes of carbon? So we have the allotropes of carbon, we have the crystalline form, and we have the amorphous form. So the one that have a particular shape, they are called the crystalline form. An example is diamond, which is the hardest known substance, graphite, and the monkey balls. So that's Buckminster fullerene. So those are allotropes of carbon. So they use them in making nanotubes and all. Then we have the amorphous form. The amorphous forms are like your coal, your charcoal, coal and so on. So carbon suits, all of those things are so you have the different allotropes of carbon. So all these ones usually exist as powder, while these ones usually exist as crystals. So that's the difference. And we are going to talk about them under inorganic chemistry, where you will learn about the different allotropes. Then we also have allotropes of phosphorus. Which one will conduct electricity here? Graphite. And why graphite? Electron that is free. So we have what we call the red phosphorus, we have the white phosphorus, and we have the black phosphorus. So those are the allotropes of phosphorus. We also have an allotrope of sulfur, right? Yes. So we have allotropes of sulfur as monoclinic sulfur, rhombic sulfur, you have plastic, rubber sulfur, so and the likes. So those are the allotropes of sulfur. You should get used to them. Then we also talk about oxygen too, which is ozone. So these are the examples of allotropes you should note, but they will ask you questions on them, and those questions you will learn them under inorganic chemistry. So, for atomic model, you just summarize all those scientists, the experiments done by those scientists, and their discovery. Let's follow 10 minutes. Oh yeah. Can I rock the board? So please don't forget those terms we just finished talking about. So atomic model is talking about the work of all of those scientists on the structure of the atom. Are you true? Where's the Google? Hello, So, for the atomic model, we are going to talk about different sciences. Emma Pariwo, Omobele. We are going to talk about scientists that postulate. So everything they did and their assumption. Who discovered proton, who discovered electron, who talked about the nucleus for a class.